So for the next part of this, what we're going to do is we're going to do buffers. So buffers are useful because you can provide some sort of area of impact, let's go with. So in this case, you've got these hurricanes, for example, and what we can do is we can see how much area these hurricanes have impacted. Now, we can do this using one field, or we can do, or one value, or we can do this using a certain field. So if we go into the IBTrACS continental data, right, and I've already kind of hinted at this one already. One of the things we have is this maximum wind speed, right? So we have this max wind speed here that is in some relation to this max wind speed USA over here. So what I've actually done in this particular case is I've changed this into a different format or a different unit. And so what we can say in this case is that if you have a higher maximum wind speed, right? So if you have a higher maximum wind speed, this probably has a little bit more impact than if you have one with a very low wind speed, right? So for example, this one's not named. This is a not named tropical storm versus this one, which is Alma, Gilbert, Wilma, Dorian, Mitch, Rita, Irma, Andrew, Katrina, right? Katrina is top 10 in this case, right? So these ones would have had, with higher wind speed, these ones are going to have a bigger area of impact. And so what we're going to do is we're going to buffer our areas of impact based on our wind speed. We could just buffer it using and say, well, for example, if we have Katrina, right, which probably is this one. Yeah. Hey, look at that. Got it on my first try. So Katrina, for example, I could say, well, it had this area of impact or a certain amount of impact that is going to have its max damage on either side of its route, right? So it's going to go through that. So it's going to come up through New Orleans and have impact on either side of it, right? So I can say, well, its major area of impact is on a certain amount of either side to it, and I could say that that's true for all of the different hurricanes. That's fine. But in this case, as we said, right, Katrina, a lot more impact than these unnamed storms back from 87, 94. So like, if it's not named, we don't even know what that is. Or maybe in this case, it's much bigger than Colin or Bertha, right? It's like, I haven't heard of Hurricane Bertha. It happened a couple of years before Katrina, right? And so with that, and also went through New Orleans. No one's talked about Bertha. And so with that, instead, what we can do is we can use this field over here to do a different length of buffer on either side, right? So buffers are going to create a polygon on either side of this with a certain distance attached to it. So in this case, make sure that we already have things like projections. Don't worry about it in this case, but if you're doing this on your own, you would want to check out what your projection is, right? Probably make sure that it's in an equidistant projection. So, but for this, what we're going to do is we're going to go back to our geoprocessing and we're going to have buffer. And we're going to see what the area of impact is. Now, you can use a regular buffer. If you click this one, it's going to tell you to use a pairwise. It does not matter, semantically speaking, in this particular case. Well, so there are semantic differences in actual differences. There's very little, for a data set like this, there's very little difference in functionality. So same thing here. Top feature is going to be what you want, right? So this is the input features. We want the hurricanes. Our output feature class, again, same thing. You can change the location using this browse button here, or you can just say, I want hurricanes, hurricane buffers, USA. Okay, so this is the hurricanes here. Now, the linear distance in this case, we're going to say instead of a linear unit, that's if you want one type. Instead, we're going to say that it's a field. So that field is going to be the max wind speed. Okay, so that is going to be what we do. So it's a field, it's max wind speed, the side type. So if I click over on this information here, so for lines and buffers, buffers will be generated on both sides of the line. For polygons, buffers will be generated around the polygon and will contain and overlap the areas of the input features. This is the default. Left, you're going to do the left side of a line. This option is not supported for input features. Right is going to be, again, for the right side of the line, not supported for polygons. Exclude is exclude the input polygon from buffer. So for polygons, buffers will be generated outside of the input polygon only. This option is not supported for line features. Okay, so this one, in this case, we don't want just the left side or the right side of it. We want it to be full. The round type, in this case, or the end type, is going to be a round. You can have this as a flat one, so it's going to be squared off, or it can be round. The method is going to be planar. This is either planar or geodesic, so which way are we using it? And then the dissolve type. So dissolve is very specific to a particular thing. Now, what I would recommend is you actually run it once without dissolve and once with dissolve so that you can see it. So I'm going to run it once without dissolve very quickly so that you can see this. It'll be very useful in this case. So in this case, what you can see is that each one of these lines has a buffer over it, right? And you can see that they're different sizes, right? So Katrina, much larger bandwidth, and yes, I'm aware that this is not as big as Katrina actually was, but this is for the purpose of seeing like where the eye of that storm went through and what that area of impact was. Okay, so each one of those has its own line, and so you can see I've got 1, 2, 3 overlapping fields in here. So if instead, now remember, if I don't change anything, it's going to just overwrite it. If I dissolve these into a single feature, right, which is what I say to do, then if I take a look at this one, what you'll be able to see is that each one of these now just has a line, or all of these now just has one polygon over it. So instead of having multiple overlapping polygons, you have just one polygon that is everything. Now, there's different benefits to doing each one of those. For this particular case, because we are only interested in the total area or the area of impact among the counties, we don't care about how many times they've been hit. We already know that. So instead, what we're just trying to get is what area of the polygon or what area of the county has been hit. And so in this particular case, this is what we're going to do with it. Okay? And so this is going to be the buffer. So now what you should have in this case is you should have the Wisteria counties, you should have the hurricane tracks, although you can probably move those down, and you have your amount of hurricanes, your hurricane buffers, and your fires. So still dealing with these 3 sets of data, okay? So next we'll be back with overlays.